Welcome to the today's session Design Against Static Load Introductory Part. In design of machine elements, there are 6 units. First one is the design against static load. Second one is the design of shaft cage coupling. Third one is the design against fluctuating load conditions. Fourth one is the power screw. Sixth one is the bolted and welded joint, and sixth one is the spring design. Today in this session we will see some of the terms or basics associated with unit number 1, that is design against static load. Design against static load. Learning objectives of the today's session. After this session you will be able to define machine design. You will be able to list the requirement and know the basic design process of machine element. You will be able to describe the types and uses of standards in machine design, and you will underline modes of failure and role of factor of safety in machine design. Now let us see what do you mean by design. Before going to machine design, the design engineering, many times in our day-to-day life we are using the word design. The design in engineering or design engineering means application of engineering to design machine, systems, tools, products, equipments and any other physical thing. It's a process of applying various techniques, scientific principles, laws, rules for the purpose of defining a device or a process or a system. It is known as design engineering. But here we are going to learn a machine design. So what do you mean by machine design? Machine design is also a process of applying various techniques, scientific principles, laws of physics, chemistry, mathematics, imagination of description of a machine. Description, imagination and description means drawing of a mechanical system to perform specific function, that is important, to perform specific function with maximum efficiency and economy. That means in machine design, or how we are going to define it, it is a process of applying various techniques and scientific principle, imagination of description of machine, mechanical system to perform specific function with maximum efficiency and economy is known as machine design. Design may be simple, complex or easy or difficult, or sometimes may be mathematical or non-mathematical. Now here let us see what are the steps involved in machine design. Basic procedure. The design process. Look at towards the left hand side here. All these are the steps which are related to design process, and towards this right hand side these are the steps involved in design of individual machine elements. The first of all I would like to describe here the design process or general design process. The first step involved here, identification of need and market survey. What do you mean by identification of need and market survey? That means the first of all, through the market survey, the need of society that we have to find out. We have to identify that need of the society or human beings. Society means human beings. Sometimes the different competitors are in the markets. Their products are available. What are their features? That means market survey which is carried out, and based on this market survey and society needs here, in second step, definition of problem. So what is the requirement? So we can define here definition of the problem. The what part, what product or system or a process it should be designed or developed. Then synthesis. And once problem statement is completed, the synthesis means how to design that products. That means how that system looks like, its configuration, that many number of sketches are drawn on a paper, that is synthesis. And from that many number of configuration we have to select the best one. That is synthesis. That means choosing best one suitable. Now suppose, take the example. Suppose to operate some, the machine, sometimes mechanical mechanism may be used by using linkages, sometimes hydraulic system may be used, sometimes pneumatic system is used. That means 3 to 4 options are there, but which one is the best one? That is synthesis here. Then after synthesis, when best configuration is decided, then analysis and optimization. Now here in analysis and optimization means design of whole that product or a system. It may consist of many number of machine elements or a components. The design of that individual components which is carried out. I will explain that the process of design of individual machine component later on. And after designing that system or a configuration, then its evaluation may be by using analytical tool, maybe by prototyping some model and tests carried out on it. After testing it, modification if required in dimension which is carried out, and final preparation of drawing, or it's a production drawing. Now this is the general steps which are involved in design process. Now here in analysis and optimization, that is design of individual component, and different steps are also involved in this analysis or design of individual components. Because suppose take mechanical gearbox. In gearbox many components are there: gear, shaft, keys, selection of bearing. Then how to design that shaft, how to design the gear or the keys. That means design of individual machine element and its procedure which is given here. Now here in design of individual component or machine element, first step is specify the function. Specify the function means, suppose shaft. What is the main function of the shaft? To transmit power, to transmit motion, or to transmit the torque. That means it rotates. When it is going to rotate, during that time different components are mounted on it, and because of that different forces which are acting on it. So we have to find out these different forces. Then material selection. Once we have calculated the different forces, then select the suitable material for that component, maybe shaft, maybe gear. Once material selection means ultimate tensile strength, yield strength, then BHN, all these are the properties associated with material. Then determine the failure mode. Failure mode means how this component is going to fail, whether it's a brittle failure, ductile failure, or we have to find out its failure mode. Then next, once determine the failure mode, whether this component is going to sustain or not. Now here in this design, it's a rational design. That means we have to find out the geometric dimensions that which, or we have to find out the size and shape of that component at which that component can sustain that load acting on it. Determine that geometric dimensions, and again we can modify these dimensions for assembly purpose and manufacturing purpose to retain the component on the shafts or during assembly. And once it is done, then here the prepare the working drawing of that individual component. This is about the different steps involved in design of machine element. Try to understand there are two processes. One is design process and second one is the design of individual component. Individual, specify function, determine process, material selection. This is about that. And in our design, while designing the different components, we are going to use this method, and for mechanical system, so we have to follow this method. Try to understand. Now let us see another, the general design process. The based on earlier, the slide here, the first step is product specification. Product specification means identification of needs, definition of problem. Take the example of two-wheeler. Now here two-wheeler. So first of all, we have to find out the needs of the society. Based on the market survey, define the problem statement. While designing the motorcycle, how much is the capacity, whether that is means in kg, then weight of that vehicle, then how much is the average or fuel efficiency. So we can take into account all this specification while defining the problem, and then we can design a motorcycle to carry that load in this way. Then second one is the selection of mechanism. While designing it, again to transmit some motion and power, different mechanisms or different, the configuration of vehicle that we have to plot on a paper, and from that best suitable option that we have to select, that is synthesis, and from synthesis final selection. Once final selection, we can note down all the elements or machine elements involved in this final configuration. That is why layout of this configuration, and once layout is completed, we can design the different machine elements which are required for this configuration or for the product or mechanical system. And again already explained the process of individual component design process and determine which type of process acting on it, then selection of material, mode of failure, and find geometric dimensions. And last one, once all the components are designed, we have to assemble it, and then preparation of drawing, maybe assembly drawing, maybe detailed drawing. Again, it should be the production drawing. Production drawing means use of limit, pitch, tolerances, surface roughness, geometric or fits also. All this that we have to apply here. Then and then it becomes a production drawing. That means in design, it involves systematic approach from known specification to unknown solution. Try to understand. The next important point is design consideration. While designing any machine elements or components, what are the important consideration? Important consideration. The broad objective of designing these machine elements is to ensure its operating capacity during the service life. That is important, and that's why in order to achieve this objective, the machine element should satisfy the following requirement. Following requirements means this requirement. One is that machine element should have a strength. It should be a rigid one. So what do you mean by strength? Ability of material to resist the external forces that causes various types of stresses. That means material should have a high strength. Then rigidity. Rigidity means ability of material to resist deformation under the external forces. The material should be rigid. That means machine element should have a high strength, should have a high rigidity. Another one is the wear resistance. Wear resistance means because of wear, what is going to happen? It reduces the life of the component. That's why wear resistance property is also an important one, and it may lead to the loss of accuracy of machine tools also. Therefore, it's very necessary or important surface hardening of the material to have a proper wear resisting property. Then minimum dimensions and weight. Along with sufficiently strong or strength and rigidity, that element should have a minimum weight. Why minimum weight and dimension? Because it is going to reduce the cost of that element. Another one is the manufacturing. During this manufacturing, reduce the part count, use the modular design, and optimize the part handling. And because of this, what is going to happen? It may reduce the reduce the labor cost. That means manufacturing cost associated with the machine elements. Then safety. Safety means shape and dimensions of the machine part should ensure safety to the operator. That is the consideration. Then reliability. Reliability means it's a probability that a machine part will perform its intended functions under desired operating condition over a specified period of time. How much this component is reliable, that is important. Then another one is the design for assembly and maintenance. It should be easy for maintenance and assembly point of view. We can easily dismantle it for maintenance purpose, or we can easily assemble it. The cost associated with that or the time, that is important. Then last one is the cost. The cost should be minimum one in general, or should be low one. So while designing the machine elements, strength, rigidity, all these are the basic requirement that we have to take into account as a designer. Then let us, because here the another important point, that is strength and stress. Now here in design of machine element subsets, we are going to use many times these two terms, strength and stress. So you should know the basic difference between strength and stress. So why this strength and stress are important? Because to avoid the failure of the machine components, strength and stress plays important role. I will explain in next session also. And during the design of simple machine component, you will get the idea how the strength and stress are important to avoid the failure of the component. So first of all, let us see what do you mean by strength. The strength, generally we are many times using this word strength, but for a material, strength is an inherent material property of the object or the component. It's an inherent material property, and the point at which when we are going to say the terms, the strength, you will find, you already studied in second year, ultimate tensile strength, yield strength in case of ductile material. So you will find here the point at which something interesting happens, that point is yield strength. Before that, what is happen or happening? After that point, what is happening? The interesting something happens. Therefore, we can say strength is nothing but a capacity of material to take the stress. And this strength depends on molecular structure and processing. Now here, another term is the stress. What do you mean by stress? Stress means state of an object when force is applied. Now take the example, suppose some metal block is there and it is subjected to some forces, maybe axial force, whatever may be the type of force. If there is no force acting on the metal block, that time metal block may have some strength, maybe 500 megapascal or more than that, because it's an inherent material property. If there is no load acting on it, that means there is no stress. But when this metal block, when subjected to some forces or some load, that time stress gets induced in it. That means state of an object when force is applied. That time stress may be 300 megapascal, maybe 400 megapascal, but strength is there, that is 500 megapascal. And if this stress exceeds the strength, that time failure of the metal block may occur. Try to understand. That's why strength is a inherent material property and stress is a state of an object when force is applied, and this force may be mechanical or because of thermal loading or thermal stresses may get induced in it. Try to understand. Then let us have a recap of this stress strain diagram. You already studied in material science and metallurgy in second year. Now let us see this first diagram or a figure. You will find strain on x-axis, stress on x-axis. This is for ductile material. And second diagram, which is for a brittle material. Looking to that diagram, you can easily say that. But what do you mean by ductility and what do you mean by brittleness? So to decide it's the material deformation, that is the important criteria. For ductile material means ability of material deform greater extents before the failure. So you will find when tensile test which is carried in laboratory, the elongation of the test specimen which is going to occur, and then it is going to fail. That means you will get the idea there is a elongation or straining of material. But in case of brittle material, you will find there is a sudden failure or sudden fracture of the material. That's why it shows negligible plastic deformation before its failure. There is no any alarm or elongation in case of brittle material. That's why it's very dangerous than the ductile. But in ductile, we can observe that material elongation on straining before its failure. That means elongation is the criteria to decide ductility and brittle material. When elongation is greater than 0.05, so you can say it's a ductile material. If it's less than 0.05, you can say it's a brittle material. The tensile strain of 5%, that is 5% means the 0.05. In tensile test decides ductile and brittle material. And that's why this diagram is applicable to ductile material, and this is for brittle. Why is it ductile? Because yield stress, ultimate tensile, then there is a elongation, and then failure point. Look at this. This is for ductile material, maybe mild state, or you can consider any alloy, no problem. Now here you will find O to P is the proportion limit. That means as the load increases, or because of this load, stress gets induced. Stress and strain is directly proportional up to P. That is proportional limit you will find here. Then another important point, from this P to U, again it is going to increase. E is the elastic limit. Elastic limit means when load is applied, there is a deformation or change in shape and size of that machine elements, and when load is removed, it regains its original position up to this E. The E is the elastic limit, or you can say that is the elastic property of that material. And here from up to O to P, the within elastic limit, stress is directly proportional to strain. If we are going to take the slope of this line O to E, you will get stress upon strain. The elastic limit, here you will get Hooke's law. Hooke's law, what is the statement of Hooke's law? Within elastic limit, stress is directly proportional to strain, and the constant of proportionality is known as elasticity, Young's modulus. Try to understand. So therefore, E is equal to stress sigma upon epsilon, that is strain. And again, strain means change in dimension upon original dimension, del L by L. And stress means force upon area. Area means cross-sectional area. And force means load which is acting on the element. The internal resisting force that we have to consider. Try to understand. Then after E, another point is Y. Y is the yield point. Yield point means after this point, there is a plastic deformation starts at this point. After removing the load, that component can't regain its original shape and size. There is some straining or elongation of the material. That means plasticity starts. Plastic deformation started at this point Y. And even though when load is applied, it is going to increase. So you will find the maximum stress limit at U, that is ultimate tensile stress, is the maximum stress or a maximum strength of that material up to which that load can be carried out. And after that you will find, even though load is applied, there is a downward, the curve goes downside. That means there is a elongation or elongation starts now in plastic phase, and F is the failure point where, or breaking point where component may going to fail here. The O to P is the proportional limit, O to is the elastic limit, Y is the yield point, U is the ultimate tensile strength, and F is the breaking or failure point. This is applicable for ductile material. Again here in case of brittle material, you will find there is no P, E, Y, directly U, E is shown. Why it is shown? Because brittle material shows negligible plastic deformation and there is a sudden failure. That's why there is no Y. Directly U means ultimate maximum limit where which it is going to fail. That's why this is applicable to brittle metal, that is cast iron. Suppose take the example, cast iron is the brittle material. Again here you will find I have drawn one line through this E dash line. The area under the curve OEA is known as resilience, and which is associated with the stiffness or elasticity also. The energy absorbed or area under the curve, you can say the resilience or energy absorbed during this during this deformation or in elastic region. Try to understand. And then F here, look at this, another line which is drawn with F. Area under this whole curve here is known as the toughness. That means by using this stress strain diagram, we can easily define ductility, malleability, brittleness, then here up to which the elasticity, plasticity, then toughness, resilience, many properties we can define by using the curve. Again here I have given one link of YouTube video where you will get the idea how the tensile test which is carried in the laboratory. It's a 3 point some minutes video. You can see by using this link, And even though you might have completed your the second year practically in our college applied mechanics laboratory of this tensile test. Then another important point, that is use of standards and codes in design. While designing machine elements for a system, we have to use standards and codes. So before that, we should know what do you mean by standard and what do you mean by standard and what do you mean by codes. Now here, look at this. What do you mean by standard? Standards means a set of specification for parts, materials and processes which are used to ensure quality, reliability and safety of the machine elements. But that means for quality, reliability and safety purpose, standards are used. Try to understand. A set of specification that we have to follow which are given. But why standards are used? It allows us for interchangeability of the parts. Interchangeability means, suppose nut and bolt which is manufactured in India having a size that is suppose M12. If I would like to use the same M12 nut and bolt in other country, so you will get same size, shape and dimensions of that nut and bolt in other country also. That is interchangeability of the parts. Suppose if we are importing some the machine elements from any other country, so no need to again import the same standard component from that country, may be available in our country or manufactured in our country. That is interchangeability. Then system interoperability, that is also important aspects of these standards. And third one, it ensures quality, reliability and safety of the parts and process. Now there are three types of standards. One is company standards, another one is the national standard, third one is the international standards. Company standard means, take the example of suppose any one of the company, Mahindra and Mahindra. Now there is one unit in Nasik, another one is Igatpuri, another one is in maybe in Andhra Pradesh, another one in Uttarakhand. More than 5 to 6 units all over country. But again, to have a standard, the specification of parts, material for interchangeability or interchangeability, the company develops their own standards. The national standards, BIS, Bureau of Indian Standard or IS codes, then DIN, Deutsch, then BS, British standards, SE is the American standard, or ANSI is also the American standards. All these are the national standards for their respective countries. Another one is the international, that is ISO, International Standard Organization, under which all these bodies, they recommend the rules, some rules and regulation framed by this body and accepted worldwide. Then it becomes ISO standards. The main important purpose is interchangeability, then uniform engineering or technical criteria, method, processes and practices to be followed while designing the components. Then another term, that is code. What do you mean by code? It's a set of rules and specification. For what purpose? Analysis, then design. That means rules and specification guidelines are given while design, while manufacturing, while testing, while erection of the products. Suppose take the example of ASME code. By using the ASME code, we can decide the value of SYT, SUT by multiplying 0.18, 0.30, whichever is minimum. That is for design purpose. The rules and specifications are given for design of the shafts, ASME code. Then rules of correct methods and materials are also comes under these codes, and which are used in certain products and processes and used to achieve safety. That is the major important one is the safety. Again, here different codes are given for the the in boiler design also you will find different codes are available. Example is ASME code. Another important point, modes of failure. Now here, before going for modes of failure, we know that different types of loads acting on the machine elements and the components during their running condition or service condition. The basically you will find static load, another one is the dynamic or fluctuating load, third one is the shock load, And fourth one is the impact load. These are the classification of loads. So but here, while designing, we are in general taking into account static and dynamic load conditions. Again, here in static load, what do you mean by static load? Is a gradually applied load or a force which does not change with respect to time. That means its magnitude and direction remain constant. That is static load. And because of this static load or a force, it induces tensile, compressive or shear stresses in component. And based on these stress values, we are deciding whether component is going to fail or not. Again, another one is the dynamic load or fluctuating load. That means fluctuating itself suggests the load is going to vary with respect to time. It does not remain constant in magnitude and direction. That is dynamic. But here in unit number 3, we are going to design the component against fluctuating load. So no need to go in detail during this session. But today we will see only the static load consideration, design against static load. Now here, when static load acting on the component, how the components are going to fail or failure modes. The component may fail due to elastic deflection, failure criteria, another which may be general yielding, failure by the fracture. These are the 3 modes of failure. Now the first one is the elastic deflection. Elastic deflection means, take the example of the shaft. On shaft, purpose of the shaft to transmit motion or a power. Different elements are mounted on the shaft, maybe gear, maybe sprocket, maybe pulley, and because of these different parts, there may be lateral deflection of the shaft. Sometimes, because of these components or parts which are mounted on it, the lateral deflection plays important role than the other failure criteria. That's why first of all we have to check its lateral deflection. Even the torsional rigidity is also important because it transmits the torque. Again here, second one is the failure by general yielding. Yielding means yield strength. If component is made up of ductile material, yield strength plays important role. That time we have to take into account the yield strength. If induced stress which is less than the yield strength, we can say component is safe. If it exceeds, the component is going to fail against this general yielding or because of this yielding. Failure of fracture. Failure of fracture means it's a brittle material failure. The ultimate tensile strength is the criteria for brittle material. We have seen in stress strain diagram, there is no yield strength, only ultimate tensile strength. If induced stress is greater than ultimate tensile strength, component is going to fail, and if it's less than, we can say component is safe. For brittle material, ultimate tensile strength is the criteria, and for ductile material, yield strength is the criteria. And for dynamic and fluctuating load, endurance limit is the criteria. We will see in unit number 3 in detail. Now another important point, that is factor of safety. Now what do you mean by factor of safety? In design, there we have to safeguard the machine elements or the component to failure, or we have to provide some margin. And that means now if yield strength is the criteria and if induced stress is less than the yield stress, we are going to say component is safe. That means what we have to do, the operating load should be in such a way that the developed stresses should be less than the yield strength. That means there should be sufficient reserve strength to avoid the accidents. That is important. And based on that, the factor of safety is defined as the ratio of absolute strength of material to the actually applied load or a force, or other term you can say FOS is equal to strength upon stress. Strength is an inherent property of a material. Upon stress means at that instant when it depends on the loading condition, the stress gets induced in it. So the ratio of absolute strength of material to the stress, you can say it's a factor of safety. But here another definition, factor of safety, failure stress upon allowable stress or failure load upon working load. Failure load means the maximum capacity of that element up to which that load can be sustained. Upon working load means service condition, whatever the load which is acting on it. Suppose if component is made up of brittle material, for brittle material, what is the maximum strength? Ultimate tensile strength. So a factor of safety for brittle material, that is ultimate tensile strength upon sigma allowable or permissible. And what is the FOS for ductile material? So what is the criteria of design? Yield strength is the criteria. The SYT upon sigma allowable. So you can see it's a ratio of SYT and sigma allowable or permissible stress. That is FOS for ductile material. What are the factors? So while designing the machine elements or system, we have to consider the factor of safety to have a sufficient reserve saying to avoid the failure of the component. But while taking the value or selecting this factor of safety, we have to consider some factors. These factors are types of load. Types of load means whether it's a static load, dynamic load, that is important. Now take the example of suppose gear. While designing the gear, we have to take into account different types of load which is acting on it. If it's a spur gear, spur gear is subjected to tensile or tangential force and radial force. If helical gear is considered, it is subjected to tangential, radial and axial force. That means type of load. Then material of the component, whether material is a homogeneous, non-homogeneous, then properties based on that we have to decide. Then next one, now suppose homogeneous and non-homogeneous. Now suppose cast iron, take the example of this cast iron. So generally if we are going to use a cast iron as a material, so you will find the value of FS should be more than compared with the ductile material. Then reliability of component. Cast iron is a brittle material and it does not show the more deformation. There is a sudden failure. That's why the FOS should be high. Then reliability of component. As the reliability increases, factor of value of increases with increasing value of FOS. Then cost is also important. As value of, if we are going to take the value of FOS more, that means cost of the element is also more, as the dimension of that product or machine element or system is also going to increase. Then quality of manufacturing. Sometimes to reduce the cost, if we are going to select some material here, but material may be cheap, but to perform some operation to achieve that the required dimension and shape, the machining cost may be more. Sometimes material cost be more, but manufacturing cost may be less. That is important. That's why quality of manufacturing is also the important factor while selecting it. Then service and working condition. Service and working condition means whether the component which is working under which condition, means whether the environment or working condition is a humid, high temperature, or that component is going to use in corrosive environment. In this way, we have to take into account service or working conditions while deciding the spectrum of safety. And then degree of accuracy in force analysis. It's okay, we are deciding which type of force is acting on it, but while calculating the load which is acting on the element, we have to consider the degree of accuracy in force analysis. Otherwise, there may be possibility of failure of the component. Uncertainty. Because of these types of load, working condition, degree of accuracy in force analysis, then material properties, all these are the uncertainties are related to the components, and that's why while deciding this, the value of factor of safety, we have to take into account these factors. Now take the example. Now here for buckling consideration, the factor of safety should be in the range of 3 to 6. Buckling means, suppose take the example of connecting rod. In IC engine, piston, connecting rod, crank. Because of this, the reciprocating motion is converted into rotary motion. That means it is subjected to, the forces. Buckling consideration is an important point in case of a crank. And that's why 3 to 6 value which is considered. Surface strength pitting. In case of gears and others or cams, the value of FS should be in the range of 1.5 to 2.5. Then another one is the endurance strength when subjected to fluctuating, the load conditions. Then FOS range 1.25 to 2, or depends on the different application where human safety is important consideration. In case of boiler design, the APOS should be high. That time no need to have a don't consider the cost and size and dimensions of the component. That time safety aspects, that is important. That means by considering all these parameters we can decide the value of factor of safety. Now during this session we have describes and discuss many things. One is the factor of safety, second one is the what do you mean by brittle material, ductile material, different types of loads acting on it, and then various phases of design process, steps involved in individual machine elements, and use of standards and codes. Based on that, these are some of the questions. The list out the factors involved in factor of safety, that is types of load, manufacturing, material property, cost, reliability, you can, and service condition. Then distinguish between brittle fracture, and that means here deformation or elongation. This is one criteria. Then elongation, if it's greater than 0.05, it's a ductile, less than 0.05, it's a brittle, and it's a sudden failure, and there is a alarm in ductile. And examples, you can get plain carbon steel, ductile material, then cast iron is a brittle material. What are the different types of loads that can act? Static load, dynamic or fluctuating load, impact load, shock load. What are the various phases of design process? The market survey is the first step, then second step problem statement, third step synthesis, fourth step analysis. In analysis, design of individual component, then geometric dimensions, and finally configuration or production drawing. Then uses of standards. Standards means sets of specification. Codes means rules and regulation to design, process, testings. And standards means it also takes into account the safety and other aspects, interchangeability. And in this way we have to proceed towards the another topics. In next session we will see the different types of stresses induced in simple machine elements. Thank you. I have referred here V.V. Bhandari's book Design of Machine Element, 3rd edition, McGraw-Hill publication. If you have any query, you please contact me at 9890426679 or mail me at pbkushare@kkwalk.edu.in. Thank you.